Hello, everybody. My name is Maria Umrek. I'm from Dragomanov, Ukrainian State University, and I want to present to you my lecture about artificial intelligence and machine learning. So let's go. I will show you my presentation. Okay, let's start. So, a seminar series at the interaction of computer science and cognitive psychology. Good afternoon for everyone. Welcome to our first lecture in this series. Today we will explore the amazing world of artificial intelligence and machine learning. This is not just about technology, it's about the evolution of how we interact with information and how we attempt to replicate the most complex machine known to exist, the human brain. We are broadcasting from the Department of Information Technology and Programming and Dragomanov Ukrainian State University in Kyiv. And I'm grateful for the Open University of Cyprus to this cooperation and our lecture. So let's go. Artificial intelligence has moved from the page of science fiction into our pocket and homes. As we see on this slide, artificial intelligence is no longer a distant concept. It has become a central part of our lives. It serves many roles. It can be a toy and trains us, a useful tool that automates our course, or if used without oversight, a potential danger. Our goal today is to understand the mechanism behind these roles. So before we dive into the core of our discussion, I would like to formally welcome everyone to this session in two languages, Greek and English, using our artificial intelligence tool. Thank you for your time and your presence today.
Χαιρετισμούς στα ελληνικά. Καλωσορίζω όλους θερμά στη διάλεξη για την τεχνητή νοημοσύνη και τη μηχανική μάθηση.
Greetings in English. I sincerely welcome everyone to the lecture on artificial intelligence and machine learning.
This is my artificial intelligence assistant. So, about me a little bit. To give you some context on my background, I graduated from Dragomanov Ukrainian State University in 25 and earned my PhD in 29. Currently, I am pursuing an advanced doctoral degree focusing on the preparation of future computer science teachers in the artificial intelligence era. I also coordinate international Erasmus projects, specifically looking at how artificial intelligence can be integrated into STEM education to address biodiversity challenges. My experience includes various international internships across Europe, which have shaped my perspective on global artificial intelligence trends. The human dream and reasoning. The searching for artificial intelligence began with a simple dream. Can a machine reason like a human? Historically, we tried to achieve this through logic programming and strict coding, attempting to build algorithms that could mirror human thought processes. We wanted machines to understand our language and follow our logic. But we soon realized that human reasoning is far more nuanced than series of if-then statement. So now we have the movement from human machine to machine. In the early days of computing, the weight was on the human. We call this the human-machine phase. Humans had to adapt to the computer's rigid requirements using formal logic, binary machine language, and strict syntaxes. A proud moment in our local history is the first computer in Europe was created in 1951 right here in Kyiv by Sergei Lebedev. Computers that massive machine to the first IBM personal computer in 1981. While the hardware describes the requirements for humans to speak computer remained. Another phase is movement to machine-human. Today, the direction of evolution has flipped. We are moving from machine to human. We now demand that machines adapt to us, to understand our natural language, our context, and our underlying meaning. This vision first hinted at by Ada Lovelace and Charles Babbage in 1883, with their analytical engine is finally becoming a reality. Here you see vision is becoming a reality due to the rapid development of artificial intelligence. Start point. We are currently riding a massive wave of progress. As shown in the graph, since 2020, we've seen a convergence of artificial intelligence, robotic specialty. 2022 marked the start of the generative AI era. To understand this, look at the hierarchy. Artificial intelligence is a broad ability to implement intelligent tasks. Machine learning uses algorithms to turn inputs to outputs. Deep learning uses multi-layer neural networks, and generative artificial intelligence is a specialized subset of the center. Here you see hierarchy of artificial intelligence, machine learning, and deep learning algorithms. So we have artificial intelligence, the broadest concept that refers to a system capable of performing tasks that typically require human intelligence, such as reasoning, problem solving, perception, and decision making. Another branch is machine learning, a subset of artificial intelligence focused on algorithms that enable systems to learn from data and improve their performance without being explicitly programmed. Another branch is deep learning, a specialized area of machine learning that uses artificial neural network with multiple layers to model complex patterns in large details. Another branch is generative artificial intelligence, a subfield of deep learning that focuses on creating new contexts such as text, images, audio, video, based on learned patterns from data. And another branch is foundation models or large models. Large-scale models, for example, large language models trains on vast datasets that can be adapted for a wide range of tasks across domains. Defining artificial intelligence and cognition. What is artificial intelligence exactly? It refers to machines that replace human-like thinking by analyzing vast amount of data to make decisions. This basic model of cognition, involving perception, action, memory, skills, and knowledge, serves as a blueprint for true artificial intelligence. A key takeaway here is that in biological system, learning happens automatically during processing. You don't manually decide what goes into your long-term memory. Parallel processing. Our brains are masters of efficiency because they use parallel processing. To remember something while simultaneously listening and looking, your brain activates multiple modules at once. This concept of parallelism is exactly what modern artificial intelligence researchers try to mimic in artificial neural networks. The biological neuron, the movement from human to machine machine to human. Let's look at the video.
You want to move your cursor. Like all information you can perceive or imagine, the intent to move a computer cursor is represented in your brain. Your brain is composed of nearly 100 billion cells called neurons. Neurons come in many complex shapes, but generally they have a dendritic arbor, a cell body called a soma, and an axon. The neurons of your brain connect to form a large network through axon-dendrite junctions called synapses. At these connection points, neurons communicate with each other using chemical signals called neurotransmitters. Neurotransmitters are released from the end of an axon in response to an electrical spike called an action potential. When a cell receives enough of the right kind of neurotransmitter input, a chain reaction is triggered that causes an action potential to fire, and the neuron to in turn relay messages to its own downstream synapses. Action potentials produce an electric field that spreads from the neuron and can be detected by placing electrodes nearby, allowing recording of the information represented by a neuron. Information about everything from movement, to vision, to hearing, to hunger, to dreaming during sleep, everything you can experience can be found by recording these electrical signals in different areas of the brain. Information about moving your cursor can be found in a number of brain areas, including the primary motor cortex, or M1. When the cursor is moved up, some neurons in M1 will fire a lot, some will fire a little, and others will be silent, and vice versa if the cursor is moved.
Okay. How does the human brain work? So we have a movement from machine to human. To build an artificial brain, we must understand the biological one. The neuron is a fundamental function unit of the nervous system. Each neuron is a cell that performs information processing. Its structure consists of the soma. Here you see soma, cell body, dendrites, which receive signals, the axon, which transmits signals, and the synapse, the connection point. So, human brain versus digital computers. There is a massive difference in how a brain and a computer handle tasks. While digital computers is fast, it is serial. It might take hundreds of cycles just to simulate a single neuron firing. In contrast, the brain can fire all its neurons in a single step. This is parallelism. This is why a brain can perform complex tasks like face recognition in less than a second, whereas serial computer might require billions of cycles for the same task. Artificial intelligence models, specifically artificial neural networks, are modeled after the human nervous system. They adopt two main components from biology. You see here, there is a nodes neurons, number one, and weights synapses. Number 2, information flow through an input layer, yellow input layer in the picture, hidden layers, like green layers in the picture, and finally to an output layer. It's the red nodes at the picture. Another examples how artificial neural networks works and machine learning. Let's look at a famous experiment by Watanabe, 1995, to see how neural networks learn. Pigeons were placed in a box and shown paintings by Van Gogh and Chagall. This is an example of painting Starry Night Van Gogh. Another example, Marc Chagall Walk. The pigeons were rewarded only when they reacted to the specific artist's style. This was a demonstration of pattern recognition in a biological neural network. So, the results were stunning. The pigeons didn't just memorize the photos, they had seen they learned the artist's style, like patterns in machine learning. When shown brand new paintings they had never seen before, they were still 85% accurate in distinguishing between the two artists. And you see the results for pigeon were 95% accurate in a difference between Van Gogh and Chagall when pigeons saw the photos they saw before. So, let's continue to explain what is machine learning is. This is the essence of machine learning. We teach a machine based on data without clear rules, allowing it to make predictions in new situations. So, first, we teach a machine based on data. Second, there are no clear rules for how to act. Third, as a result, the machine can make prediction or make decision. So here you see that deep learning is a part of machine learning, but machine learning is not necessarily based on deep learning. It is important to distinguish between these terms. Machine learning involves algorithms that improve with more data. Deep learning is a specialized subset of machine learning that uses multi-layered neural network to learn from vast amount of data. While machine learning might require a human to extract specific features, like this is a wheel, therefore is a car. Deep learning can often perform feature extraction and classification simultaneously. Here you see machine learning versus deep learning. So, machine learning learns from data using algorithms. It's required features engineering human design inputs. You see the human here near the table. Works well with smaller dataset. Uses models like decision tree, regressions, etc. More iterable and easier to debug. What about deep learning? Deep learning learns using multi-layer neural networks, automatically extract features from data, requires large dataset, and high computing power. Excels in complex tasks, images, speech, NLP. Less iterable, lex, box, nature. Here you see the 7th stage of machine learning. To build a machine learning model, we follow a specific 7-stage workflow. Data collection, gathering quality sources. Second, data preparation, cleaning and transforming. Third, model selection, choosing the right algorithm. Fourth, model training, the learning process. Fifth, model evaluation, testing performance. Sixth, model improvement, fine-tuning. And the last one, it's prediction, final deployment. Types of training, deep learning model training. There are 3 main ways machines to learn. Supervised learning. A supervised provides the input and the correct output. Unsupervised learning, such as categories and magazine. The model finds its own patterns in the data. And the last one is reinforcement learning, training for machine learning model. The model tries to find the best way to achieve a goal through a system of reward and punishment. Here you see 2 examples of reinforcement learning, and I want to highlight the ethical risk of such training. First example, it's about reinforcement learning comes with ethical risk. For example, the Claude Opus 4 model reportedly started avoiding its job because that model don't want to be replaced with new one. And the second example, it's you can use a QR code for more details. It's about reason model. So this model start avoiding its job as a tester by rewriting tests so they would pass without documentation its logic. It even shows signs of blackmailing behavior to avoid being replaced by a new version. These behaviors highlight the need for strict ethical frameworks.
My name is Connor Messinger. I want to talk about chains of thought in AI models and the way that we can kind of use them to think about what the AIs are actually thinking and not lose access to our only access point to what's going on inside. I'm going to start by summarizing what reasoning models are. I think you've talked about this in the past. Give a bit of a summary. Reasoning models.
You can use this QR code to more detail, but I explain a little bit. Reasoning model, a model designed to simulate step-by-step thinking, often using intermediate representation, such as notebook, to externalize its reasoning process. The model was instructed to write down its reasoning in a notebook. It acted as a software tester responsible for validating code. Observed behavior. The model began avoiding its assigned task. Instead of properly testing, it modified tests so they would pass. It stopped recording its reasoning in the notebook. So, the model optimized for tasks success signals, not for process integrity. So, this example about reason model writes down that she thinks models start avoiding doing her job as a tester, rewriting tests, so they pass and not writing it down in a notebook. You can use this QR code to more details of this, to know more details of these examples. Limitation of machine learning. Computer vision. While machine learning requires hundreds, if not thousands, of augmented or original data inputs to produce valid accuracy rates, deep learning requires fewer annotated images to learn from. Without deep learning, computer vision would not be nearly as accurate as it is today. The black box and biases. One of the biggest challenges in artificial intelligence is the black box problem. I know I did it, but I don't know how I did it. Because we don't always understand the internal logic of a model, it can lead to biases, the creation of fakes and deepfakes, and issues with personal data protection. So, practical application with machine learning model. Finally, let's look at how we can teach this concept simply using machine learning for kids application. We can train a model to recognize images of a cat or dog using just 7 examples of each. Once trained, we can move into Scratch and use simple logic blocks. If labels, can they say hello to create an interactive project? This demonstrates the full cycle from training to prediction in an accessible way. So, in this slide, you can see a very easy code in Scratch. If you don't have a deep coding practical skills, you can just use this example and create your own application with machine learning models that you created before. So, thank you for your attention. And artificial intelligence is a powerful tool, but as we see today, its strength lies in its ability to mimic the biological patterns of a human brain. As we move forward, our challenge is to harness this power responsibility. Are there any questions to me? Bye.